I want to talk about polynomial functions. Now, the definition of a polynomial function is written on the board here, and I want to walk you through it because it's kind of a little bit theoretical. You've got a polynomial function is one of the form p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and so on, plus a sub 2x squared plus a sub 1x plus a sub 0, where the numbers a sub I are constants and n is a non-negative integer. Now, what is a polynomial? It's really just a finite sum of power functions. Each of these guys here is a power function, right? You've got x to some integer power times a coefficient, some constant. And there may be so many constants that I need to number them with an index. I can't just go a to z, assuming that there are 26 of them. So it's always some constant number times x to an integer power. Now, the number n, when we write it in this form with descending powers, the number n is called the degree of the polynomial. That's the highest power of x that you find in the polynomial. And the term with the highest power of x is called the leading term, right? All of these are terms of the polynomial, but this is the leading term, even if it's not written first. The term with the highest power of x is the leading term. And a sub n, the number in front, is the leading coefficient. So let's take a look at some examples. I got 5 examples here. F of x equals 12x minus 5. This is a polynomial, right? Constant times x to the power 1 minus constant times x to the power 0. The leading coefficient here is 12, right? The leading term is 12x, so the leading coefficient is 12. And the degree, that's the power of the highest power of x, is 1. So this is a degree 1 polynomial. G of x, 2x squared minus 5x plus 6. This is the leading term. This is the term with the highest power of x. The leading coefficient is 2. And the degree, the power of the highest power of x, is 2. So quadratic, right? Functions that are polynomial functions with degree 1 are linear functions. And with degree 2, quadratic. Now what about this one? H of x equals 4x cubed minus x to the 4th. Here, the term with the highest power of x is negative x to the 4th. This is the leading term. And so the leading coefficient would be minus 1. Don't forget this minus counts as a coefficient. So negative 1. And the degree would be 4. A constant function, k of x equals 9. This is still a polynomial because we think of it as 9 times x to the 0. So the leading coefficient would be 9. And if you think of this as 9 times x to the 0, the degree is 0. This is a 0-degree polynomial. All constant functions are 0-degree polynomials. Now, m of x is not written in expanded form. It's written in factored form. So we have to figure out what the leading term is going to be. I don't have to multiply this all out. I just need to multiply enough to get the leading term, which is 3x cubed, right? This is going to give me the leading term, the highest power of x. So the leading coefficient will be 3, and the degree will be 3. So that's what we call a cubic polynomial. So remember, polynomials are basically just finite sums of power functions, right? Constant times x to an integer power. And the leading term is really important. The leading term determines the end behavior of the polynomial, as we'll see. And so we need to be able to find out the leading coefficient and the degree of the polynomial in order to determine its shape.